Thank you for the invite. Welcome, everyone. Um, as Tony was mentioning, I do a lot. My actual title at ServiceNow is Director of Product Security, where I lead a team that specializes in threat modeling and a bunch of other things in order to help our development community build secure and resilient software. Outside of that, I lead a number of initiatives around the software supply chain, including the OWASP Dependency Track Project, which is a reference implementation for how to consume and analyze SBOMs. I am the chair of the OWASP CycloneDX Core Working Group, as well as ECMA TC54, which is a technical committee that is standardizing not only CycloneDX, but a lot of other complementary specifications dedicated to the software supply chain. So if you're interested in that kind of work, reach out to me. I'm the leader and co-author of OWASP Software Component Verification Standard, or SCVS, which I'll be talking a little bit about today. Um, Highly involved in the package URL specification, which is also going through TC54. We're hoping to make that an international standard later this year. And in my abundance of free time, I the vice chair of the OWASP Global Board of Directors, where I try to help with the mission of the foundation to achieve, no more insecure software through education, outreach, and whatnot. So with that, the most important thing on this slide is obviously my contact information. Feel free to reach out anytime. Um, we all kind of know a little bit, hopefully, of what is the software supply chain, but I'm just going to level set for the next couple of minutes because it's going to provide a foundation for the rest of the talk. But the software supply chain is obviously very complicated and intricate. Obviously, it's your first party code and all of your third party libraries, container images, etc. AI models, because I heard AI is a thing now. Um, we've got all of your build processes, how you package software, your pipelines, your compilers, everything that runs test suites within your CI/CD pipeline. Everything for delivery, including where you're getting artifacts from, where you're publishing artifacts to, your CE systems themselves, anything that orchestrates containers, anything that has, a repository of some sort to where you're actually, publishing applications to. It could be the Apple App Store, Google Play Store, some other store, any kind of over the update kind of mechanisms, update mechanisms. It's really kind of complex, right? The attack surface of the software supply chain is quite massive when we actually think about it. It's almost too much to kind of comprehend all at once, which is why, as an industry, we primarily try to decompose it into smaller, more bite-sized chunks so we can truly understand a specific domain and start reducing risk in that specific domain before we start tackling another one. um, in reality, right, these are all the kind of things that were on the previous slide, but in reality, if any one of these things go bad, your application that you're building, the application that you're purchasing, whatever, could theoretically be compromised. It could contain malicious code. A really good friend of mine, Jeremy Long, he's a security researcher, and he's quite honestly, he's one of the most brilliant people in the software supply chain that I know. But he actually did a talk at Black Hat a couple of years ago about how just building software um, could create reproducibly vulnerable builds. And so the resulting artifact that you were building, it was the same hash value, the same checksum over and over and over again. And all the third party code all the first party code was, free of any kind of malicious thing. It's really how the third party code was tested, honestly, that introduced some of these vulnerabilities. So we're doing a lot of things in the software supply chain. I don't think we're doing quite enough to get the level of assurance that we all want. But when you look at it from a process perspective, whether you're using a more modern agile type of approach or more traditional, you're basically going to have various different processes that you go through in the course of developing software. And throughout this entire process, any one of these places, and obviously there's a lot more involved here. This is just some high level overview, but at any point in here, there are so many things that can go wrong that you can end up with an application that behaves in a way that you did not intend it to behave. Um, when we're developing software, there's a couple of different models that some organizations use, and I would highly recommend every organization adopt one or the other or both of these models. The one is BSIM. BSIM has been around for a very long time. It is currently a product of Black Duck, but it's a research-based project where they go into organizations and observe the behaviors that that organization does in the course of developing software. They don't prescribe anything. They observe, and then you can compare yourself against peer organizations like financial services or fintech or software companies, etc. OWASP SAM is prescriptive. It is the opposite of BSIM. They don't, observe anything. They prescribe what you probably should be doing in the course of developing software. If you're not using any one of these models, I would highly encourage you to do so. But adopting one of these is only going to get you so far, which is why, when was it? I think it was 2020, I believe it was me and a few other folks that were highly vested in software supply chain security set out to create something that could fill in some of the gaps. And what we came up with is the Software Component Verification Standard, or SCVS. I'm just going to read the description of SCVS because it probably does a better job of doing it than I would. The SCVS is a community driven framework for identifying activities, controls, and best practices, which can help in identifying and reducing risk in a software supply chain. Sounds easy, right? Um, Not so much, but it is a start. For those of you that are familiar maybe with salsa, it's kind of like salsa. SCVS is more broad in its approach. It's not as deep in kind of its recommendations. So if you're used to salsa, this is something very, very similar. Like all OWASP verification standards, there are multiple levels, and we'll talk about what those levels mean in just a moment. But SCVS is included in its entirety in NIST SSDF, which is SP 800-218. So if you have any kind of requirement on the NIST Secure Software Development Framework, you're actually having to attest to SCVS as part of that SSDF requirement that you may have. Not everybody has that requirement, but if you are selling to the US federal government, for example, that is a hard requirement. I know many financial services organizations have also adopted SSDF, and other world governments are recommending and adopting SSDF as well. So I think CISA has done a fairly good job of harmonizing SSDF across the industry. It is ideal for SCVS is ideal for assessing your first party capabilities, how you actually build, deliver software with a certain level of assurance, which is the key word, as well as it's ideal for evaluating your suppliers. And within the text of the SCVS, there are recommendations on how to do both of these things. So I highly encourage you to check that out. In terms of the coverage that SCVS covers, number one is just knowing what you have, right? Just the inventory of things, and it's not just software; it's other things as well, right? Cryptographic assets, the inventory of it all. Um, then how do you represent that inventory? Once you know the inventory, how do you represent that? Well, that's the second category with software bills and materials. The third is build environments themselves, which can be very, very tricky to harden and create any kind of assurance of what you're building is actually what you think you're building. Four is package management, which primarily focuses on modern software development practices and the use of modern package managers. Number five is the types of analysis that you can perform against the components, what you actually know what the inventory is. And number six is pedigree and provenance. What were the changes made to these third-party components over time? Who made them? What is the authorship? Where did things come from? That sort of thing. So these are the control families within SCVS. Like I said earlier, all OWASP verification standards, and we have several of them. I would highly encourage everyone to check them out. There's some phenomenal work that's gone into ASVS and a bunch of other verification standards that we have. But for software component verification standard, these are the levels. Level one is just the implementation of best practices. Level two is if you have regulatory or contractual requirements, and this is really where you start being able to introduce risk management frameworks into evaluating how mature you are with respect to the assurance of your resulting artifacts. Level three is really for that critical infrastructure. This is the stuff that, if you really, really care truly and want to invest all possible resources into hardening your software supply chain, this is really the level to achieve. I don't know a lot of organizations that really achieve this yet. Level two, quite honestly, is very, very difficult to achieve. But that's where most organizations, I believe, need to eventually end up with. Like I mentioned earlier, there is an entire section for software bills and materials, but one of the unfortunate realities is that um, we've kind of, unlike other industries, whether it's automotive or whatever, we seem to have um, created a bill of material based on the type of thing that we're inventorying, which is not ideal in any sense. If you're creating an automobile, right? You have a bill of material, for example, for maybe your dashboard, and your dashboard might include maybe an instrument cluster. Your instrument cluster might contain your speedometer, and your speedometer might include plexiglass and capacitors and LEDs and all these other components. Well, that industry doesn't have a plexiglass bill of material. It doesn't have an LED bill of material. That would be utter insanity. But that's kind of what we have in the software world, right? We've got software bills of materials. We got bills of materials specifically for the services. We got bills of materials for the cryptographic assets, bills of materials for the AI models, the data cards, etc. It's not ideal, but that's what we currently are living with. So when we're talking about bills of materials, I'm going to be talking a little bit about the full stack of things, not just software. But I'm certainly not going to do the typical SBOM talk that you've probably heard a number of times. That is not this talk. Um, but I do need to mention the NTIA minimum elements. Now, the National Telecommunications and is it Information Administration, I believe it is, Several years ago, they created through a consortium, they created these minimum elements. And while this is a good starting point, minimal fields have truly minimal benefit. You can do basic vulnerability management with those minimal fields, but not a lot of other things, which is truly unfortunate. If you have a bill of materials, there's a lot more things that you could theoretically do if you had just a little bit more data. So what other things should you care about? As I mentioned earlier, we're going to be talking a lot about the full stack. And while I am heavily invested in CycloneDX because of its full stack nature, um, SCVS is actually BOM format agnostic, right? If you're using SPDX, fine. If you're using some other format, fine. It actually works. But again, I'm really, really vested in Cyclone. It does a lot other things other than just software bills and materials. So if you want to represent the hardware or the services or the models or the cryptographic assets, etc., you can represent all this data in CycloneDX today. So that's really what we want to care about. Now, within the CycloneDX community, we have a number of guides that are available, and the guides are really there to supplement um, the usage, the real world usage of the specification, right? Reading and understand the specification is one thing. Knowing how to apply it is something entirely different, and that's what these guides are. They are a way for you to get more familiar with the capabilities and start moving you in a way where you can actually start applying this in your respective organizations fairly quickly, right? CycloneDX is a fairly easy to adopt standard. Now, one of the sections in the authoritative guide to SBOM is specifically about quality. And we've defined a number of different dimensions for quality of an SBOM. Um, I'm going to skip the first two for the moment and start with life cycles, techniques, and confidence. Life cycles is really the idea of when in the software development life cycle uh, did the data actually come into play, right? If, for example, the uh, if you are building software and you have the source code for that software, you're typically going to have, not always, but typically you're going to have a little bit more insight into the actual software components that are being used versus maybe analyzing a binary after the fact and you don't have the source code for that. So representing the life cycles that the bill of material was generated in is one dimension of quality. Uh, Life cycles is a feature of CycloneDX. To a lesser extent, it's also supported in SPDX as well. The techniques used and the methods and techniques used to identify a component. This is also very, very important dimension of quality. The, for example, if you have again the source code of a piece of software, modern package managers use ways to via a text file to say, well, I want this third party component, this open source component, whether you're dealing with Maven or I'm sorry, Java or JavaScript or Python or whatever the language is, there's a mechanism for you to specify what dependencies you want. Um, that is one way that is one technique that you can use to identify what a component is. There are much better techniques, however, including, looking at maybe the hash of that component, doing hash comparisons, doing comparisons of the AST fingerprint, the abstract syntax tree, and creating a fingerprint of that. There's all kinds of different techniques that you can use to identify what a component is. That's also a really important dimension of quality that CycloneDX natively supports. The confidence also, the confidence of each technique is also kind of used as a dimension of quality. So, for example, um, the the package manifest, like for Java or JavaScript or Python, your manifest file, your pom.xml, package lock.json, etc., is not going to you're not going to have a very high confidence if that's the only thing that you are relying on versus maybe a checksum verification or an AST fingerprint or some other kind of technique which might actually have much higher confidence. So that's also another important dimension of qualities. Both the techniques and confidence are capabilities that are unique to Cyclone DX. The first two are specific to SCVS, and this is kind of where we really get into the meat of truly what SCVS is. The breadth, the coverage of the types of different data, and the depth, right? How difficult is it to kind of figure out that data in the first place? So if we were to look at this from a analysis perspective, we would see like the confidence techniques and life cycles on the lower left hand side. Those are Cyclone DX. The breadth and depth is on the upper right hand side. But we can now start to create um, uh, a pathway for what type of quality SBOM we want to achieve, right? We might be in the green right now, which is maybe I should have chosen another color, but maybe that's where we're at today, right? We've got pretty good depth of things, and our techniques are okay, but we're not we're not concentrating on some of these other areas, right? The techniques maybe have low confidence and the amount of data is not as good as it should be, and maybe we are not in the software development life cycles that we should be. Maybe we're after software has already been built. So we can use these quality dimensions to create a map of maturity. And that's essentially where the SCVS BOM maturity model comes into play at. So the BOM maturity model complements SCVS, but it's an entirely different thing. And the model is a formalized structure. It contains a formal taxonomy of different types of data that is possible in a bill of materials, not software bill of materials, in a bill of materials independent of the bill of material format. Again, Cyclone, SPDX, whatever, it doesn't matter. Each entry in the model contains a unique identifier, description, and other kind of data that describes that entry in the taxonomy. And it includes a level of complexity or difficulty in supporting that type of data. The model is a benchmark. You can evaluate bombs that you are receiving, maybe from suppliers, maybe from your own first party developers. You can use it as a benchmark to evaluate them against organizational policy if you have them. You can evaluate bomb generation and consumption tools with this approach. And you can also evaluate the BOM formats themselves. So if a format doesn't have the kind of capabilities that you want, well, maybe you should either work with that format or possibly investigate another format that actually has the types of data that you need to support for your various use cases. Finally, the model is customizable via profiles. We took a very, very different approach than maybe some of the other things that you've heard of. What we did was we created a way to represent different types of data and our and the importance of that data in what it is that we want to achieve. The reality is that different stakeholders have different types of needs. There was an interesting observation that was made a couple of years ago. I'm not going to mention any names, but a very famous company had a bill of material tool, and it would generate a bill of material for a given piece of software. And you would analyze that bill of material and you would not find any vulnerabilities. Yay, great, right? Unfortunately, the resulting bill of material didn't have the fields necessary to support vulnerability management. So, of course, when you analyzed it, you were never going to get any vulnerabilities ever. Um, Recognizing that different stakeholders have different needs for different types of data is what profiles are all about. So you could create profiles, for example, for your legal team or your procurement team or your application security team versus maybe your AI security team or your operational security team, right? So you can create profiles based on the stakeholder roles. The difficulty levels, um, we had to make some ways to essentially have a formal definition for what we think was going to be difficult. Put that in air quotes. Um, but we needed a way to say, well, this type of data, we can do it because of X, Y, and Z. So we needed a repeatable way to do this. For the low difficulty, the low complexity, simple to obtain through first-hand automated observation using existing tools. Pretty simple. Moderate difficulty to obtain through automated observation using domain-specific tools and plugins. High difficulty, difficult to obtain, requiring manual effort, human observation, or access to data held within restricted domains. Those are the definitions. And again, this is the depth that we're talking about in terms of the quality metric. This is kind of where this fits in. So let's look at an example of an entry that is in the BOM maturity model. Again, everything in the model, it's a hierarchical model, as you would expect. It is a taxonomy. Everything in the model does have a unique identifier. We use URNs to identify everything. And this is talking specifically about software identity, um, which is not a hard problem, right? It's naming things is easy. Um, Um, the domain for this is resource kingdom software. The name of the thing is identity, and it is what you think it is, right? It is a low difficulty thing because again, we have package managers that using existing automated tools, by, per that definition, can represent the identity of things. Now, again, that technique may not necessarily have high confidence, which is why you may want to use other techniques when you are looking at the overall quality of the SBOMs that you might be wanting to evaluate. But in terms of a difficulty level, this starts at a very low difficulty. It can get to, going back to this, it can get very, very difficult if you actually put in a lot of effort, write your bunch of specialized tools, actually have humans in the loop to validate those outputs. Sure, this can get very, very difficult, but the barrier to entry is actually quite low, which is why the difficulty is low. Another example is software that might be fetched remotely at runtime. So again, we have the identifier and we have the description, an instance of software that must be retrieved on demand at runtime. No, I can't represent that in a package lock.json or any kind of other package manifest, right? I usually have to use specialized tools to be able to identify that type of dependency because it's not your traditional dependency. It's very common, but it's not a type of dependency that I'm going to have in my dependency graph by default in my build process. So it does require specialized tools, but it's also not that difficult to be able to achieve. So this one actually has moderate difficulty. As I mentioned earlier, SCVS does support profiles, and this is an example. This is not a complete example. This is a snippet of a profile that you can create. This one is the snippet for the NTIA minimum elements, and let me just kind of walk through this a little bit so you get an idea. I apologize in advance for the folks that do not read code. This specific piece of snippet is in JSON, but I will kind of walk through what this does. So the very first line is basically identifying, hey, this is the type of format that we are using. In this case, it's the BOM Maturity Profile. This is the name of the profile that we are creating, right? This is the NTIA minimum elements, version 1, description of what it is, and the elements themselves. Now, the structure is really about where in the bill of material the data is going to the data should be. In our case, we want two different parts of the structure of the bill of material to have this information. The metadata is really about the part of the bill of material that describes what the software is, right? If I've got an Acme Commerce Server, right, 1.0, well, that's the metadata, right? So that's the structure of the bill of material. The inventory is like all of the third-party dependencies that is in that Acme application, right? All my third-party libraries, whether they're open source or commercial, doesn't really matter, but all the other inventory, including software, services, etc., that is part of that inventory. Now, within both of those structures, I want these following identifiers because, again, NTIA minimum elements defined a bunch of different types of data. Well, these are the identifiers, the SCVS identifiers for the types of data that NTIA said these are the minimum things we want. So we have the supplier. We have the coordinates, which goes to the identity of things. We have the software identity itself, and we have the relationships in terms of assemblies, which is the idea of software including other pieces of software. We are putting a really high weight on this. So all of the elements, each element, which we're still in the element structure here, each element has a certain weight. So you can say, well, things, right? It's a way to say, well, these are my absolute required things. These are my nice to haves, and even of my nice to haves, I might even prioritize those as well. So this is kind of your way between the weight and required fields. This is your way to kind of prioritize the types of data that is represented in this profile. Now, this is just one profile, right? You can create other profiles. Now, we do provide an NTIA minimum elements profile as part of the SCVS project, but you can create your own profiles. I know I went through a lot of material, and this is really kind of an introduction. I wanted to give you some resources on a few different things. So check out scvs.owas.org. That's the official homepage of the OWASP Software Component Verification Standard. And if you're interested in finding out more about CycloneDX, specifically on some of the quality things that we have as part of the specification or some of the other stuff, check out CycloneDX.org. And with that, I will pause for Q&A.